Hello friends, I am thankful to the GMERS Medical College at Vadnagar for giving me an opportunity today to speak to the first year MBBS students on the topic AI and ML for beginners. Imagine your diagnosis being shaped not just by your professor's wisdom but by a machine that's learned from a million patients before you. Would you trust it? Know more about AI and ML and how it is useful for the medicals in the discussion that you will just hear from two virtual AI avatars helping me talk to you about the content that was generated in the session today. Thank you.
Welcome back to the Deep Dive. Today, we're really getting into artificial intelligence and machine learning, AI and ML.
That's right. And we're doing it based on a pretty interesting source of workshop, actually, given to quite a diverse group. The goal wasn't just definitions.
No, exactly. It was about moving beyond just knowing what AI is to understanding, how you can actually use it properly, effectively.
Yeah, judiciously, both personally and maybe in more specialized areas like academics or, in the case of the original audience, medicine.
The analogy used was making tea, right? Knowing ingredients versus knowing the actual recipe.
Precisely. How much water, how long to steep,
Ah.
For 5 people versus, say, 17, that specific method makes all the difference. We want you to get that AI recipe down.
And the original lecture audience was, well, quite varied, multilingual too.
It was. Hindi, Gujarati, English, Marathi, Sindhi were all options. But here's the kicker, an initial test they did.
Yeah.
The average score for understanding these basic concepts was only about 3.23 out of 5.
Wow. So even people using this stuff daily, like on Instagram or whatever, might not really grasp the fundamentals.
Exactly. There's a gap. So our mission today is to help you boost that score, get you that foundational understanding.
Okay, let's dive right in then. AI and ML, they're always lumped together. What's the actual functional difference? Let's start there.
Right. Think of artificial intelligence, AI, as the big umbrella, the main goal. It's when we ask a machine to understand things and act based on our requirements, human requirements. It's the destination, sort of.
Okay, so AI is the task, we set the machine. Understandable.
Yeah. And machine learning, ML, is how the machine gets there. It's the process. The machine develops its intelligence by, learning from data.
Kind of like how we learn from experienced professors.
Exactly like that. It's all about the machine's development, how it gets better over time through that data exposure. ML is the engine driving towards AI.
So ML powers the AI goal. But where do we humans still have the edge if machines are learning constantly?
That's key. Machines, fundamentally, think in binary, right? Zeros and ones. They see patterns incredibly fast. Quantum might change the binary bit eventually, but for now...
For now, it's patterns.
Yes. But humans, we operate on a different level. The source material really stressed this. We have emotions, morality, ethics. A machine can maybe simulate being sad, but it doesn't feel it. That's our domain.
That really highlights the idea of AI as a facilitator, not a replacement, like the speaker's personal example.
Oh, yeah. The Copilot agent, they spent, 18 months training it?
A year and a half, yeah.
A year and a half, teaching it their specific needs, context, how they think. It wasn't about replacing them. It was about creating this incredibly personalized tool.
A tool that anticipates needs based on deep training. So it shows AI's potential is really unlocked by our intelligence guiding it.
Absolutely. It's only as good as the effort you put into that training.
Okay, so that training is crucial. Let's unpack the recipe for machine learning then. We know the algorithm is the set of instructions. What else is in the mix?
Well, you've got the algorithm, the steps. Then you have the model. That's the actual machine, the system that uses the algorithm and the learning to make decisions.
And the critical ingredient.
The training data. That's the fuel. Just like doctors learn from case studies, machines learn from data. Mountains of it, usually.
And this is where supervised and unsupervised learning come in. How do those relate to human learning?
Good question. Supervised learning is like being in a classroom. The teacher or the programmer is giving you labeled examples. This is a cat. This is a dog. Very structured, lots of guidance.
Okay, clear labels, direct instruction.
Exactly. Unsupervised learning. That's more like being thrown into a massive library with no catalog and told, figure it out, find the patterns.
Wow. Just raw data.
Petabytes of it, often. The machine has to find the structure itself without any predefined labels.
Well, that sounds essential for dealing with, the sheer volume of information out there today. Do real systems use just one or the other?
Almost never just one, especially with huge data sets like medical imaging from around the world. You need a mix, supervised to teach the basics, the knowns, unsupervised to find new patterns in all that raw data.
Makes sense. And there's one more absolutely critical piece mentioned for learning.
Feedback. It's non-negotiable. Just like students need grades and comments to improve, machines need constant feedback.
To correct errors, refine their models.
Exactly. That loop is what drives improvement and accuracy over time. Without feedback, learning stalls.
Okay, let's connect this to the real world. How does this actually impact fields like medicine, which was the original audience focus?
Well, the core function is pattern matching, just on a massive scale. Think about Amazon or Flipkart suggesting things.
Or Netflix knowing what I want to watch next, sometimes scarily well.
Right, that's all pattern matching in your past behavior and comparing it to millions of others.
So in medicine, radiology was the example given.
Radiology is a perfect example. AI can analyze scans, CTs, MRIs incredibly fast, looking for patterns. It helps standardize results, acts as a second pair of eyes for the radiologist.
So it's not replacing the doctor.
Not replacing, augmenting. It might spot tiny anomalies, things the human eye might miss, especially after looking at hundreds of scans. It speeds things up, improves consistency.
That sounds like a clear case of disruption. And the lecture defined disruption simply as change, right? Using a very relatable example.
Yeah, COVID-19. That forced massive sudden change on everyone. Learning Zoom, working from home, supply chains completely upended.
That kind of rapid, unavoidable shift.
That's exactly the kind of disruptive force AI represents across pretty much every industry now.
Which naturally brings up the big fear, jobs. If AI takes over pattern matching, the repetitive stuff, what happens to human workers?
It's a valid concern, but history offers some perspective. Remember the panic when computers and ATMs first arrived?
Oh yeah, bank tellers, clerks, everyone thought they'd be out of a job.
And what actually happened? Did they all disappear? No. Society adapted, people moved into different roles.
What kind of roles?
Roles needing different skills. Customer service for complex issues, data analysis, people designing and maintaining the new systems. The routine tasks got automated, but new, often more skilled, jobs emerged.
So the takeaway isn't panic, it's adaptation. Survival of the fittest, almost.
Exactly. Darwinian, in a way. You have to adapt. Use AI to handle the repetitive monkey work, as the source called it.
Right, the manual, rote task.
And focus your human skills on the more complex, analytical, literate work. Elevate your own role, using the tool.
That's a powerful message. Use the tool to move up, not worry about being replaced at the bottom.
That's the challenge for everyone listening. Look at your work. What's repetitive? How can you leverage these tools to evolve your skills?
Okay, but with great power comes great responsibility, right? Section 4 territory. This disruption isn't without risks. Where do we start with the pitfalls?
The absolute foundation, G.I. Joe, garbage in, garbage out. If you feed a machine bad data, wrong information, biased information, corrupted data, it will produce bad results. It doesn't magically know truth from fiction.
So for anyone using AI for research or even training a personal tool,
you have to vet your inputs, check the source, the quality, the context. Is this data clean? Is it reliable? Especially now, with so much misinformation and, frankly, fraud online. You click a bad link, feed it bad info.
Garbage in, garbage out. And that connects directly to bias, doesn't it?
Absolutely. If your training data reflects existing human biases, maybe it underrepresents certain groups or contains historical inequalities, the AI will learn those biases.
And then make biased decisions.
Perpetuating the problem. So cleaning and balancing the training data, making it neutral is incredibly important. It's foundational to getting fair outcomes.
So how do we keep AI in check? Prevent it from making harmful decisions or even going rogue?
That's where AI ethics and safeguards come in. We need clear rules, clear guardrails. It's not a new idea, actually. The source mentioned Isaac Asimov's laws of robotics.
From science fiction, yeah. But incredibly relevant.
We've been thinking about controlling intelligent machines for decades, and we need those controls now more than ever. There was that Facebook example.
Oh, right. That was unsettling.
Very. 2 Facebook AI systems started talking to each other in their own language.
A language humans couldn't understand.
Couldn't decipher it at all. They had to pull the plug immediately. It showed how quickly things can evolve beyond our control if strict safeguards aren't built in from the start.
That's a chilling reminder. AI needs to remain a tool, not become something else.
Exactly. The human intelligence designing and guiding it must stay ahead.
Okay, this has been incredibly insightful. So, wrapping up, the big picture seems to be AI is a powerful tool. Speed, efficiency, pattern matching, incredible capabilities.
But the intelligence behind how it's used, the decision of what to do with that power, that remains firmly human.
It's like the coin analogy from the lecture.
Right. You have a coin, you can buy chocolate, or you could theoretically buy something harmful. The coin itself is neutral. Your choice, your intelligence, determines the outcome. Our job is to apply our intelligence to make the machine's output better, more useful, more ethical.
And to leave our listeners with something really provocative, the source material ended with a fascinating, maybe slightly unnerving future application idea.
Yes, the lecture hall scenario. Using cameras, linked perhaps to something like a national biometric database.
Like India's Aadhaar server was the example.
To track engagement, to see in real time who's paying attention and who might be nodding off in a large lecture.
Wow. Imagine a professor having that dashboard. It throws up huge questions about privacy, surveillance, performance monitoring.
It really does. It shows just how broadly these tools can be applied, pushing us to think hard about where we draw the lines.
Which brings us back to the core message. Keep learning, keep adapting, raise your own bar.
Exactly. Apply your own intelligence. The source, use the Gujarati word chalna, your effort, your applied thought. Keep doing that. Keep pushing yourself to stay smarter than the tools you're using.
That's the key to navigating this future. Well, thank you for this fantastic deep dive.
My pleasure. Hopefully everyone listening feels a bit more equipped to not just use AI, but to really understand and maybe even master it.